Hello guys, welcome back to another video. Today we are going to look at the geography syllabus. We know that exam is upon us and you have been studying for months from your past paper questions. But what about using the geography syllabus to get a grade 1? Alright, so we're going to begin with the syllabus. It says we should look at the theory of plate tectonics. Now, do you know what plate tectonics is? If you're thinking that it is the idea that the Earth's outer layer, which is called the crust, is made up of a big pieces like a jigsaw puzzle. Now, these pieces are called plates and they move slowly over time, floating on a softer layer beneath them. Now, sometimes the plates move away from each other, sometimes they crash into each other, and sometimes they slide past each other. This movement causes things like earthquakes, volcanoes, and the creation of mountains. So, plate tectonics explains how the surface of the Earth changes over time. Now we're going to look at what are the types of plate boundaries. There are three main types of plane boundaries, and each one describes how the plates move. The first type of plate boundaries, I want you to think pulling apart. I want you to think about the phrase pulling apart. Now, the first type of plate boundary is divergent boundaries. Now, this is when two plates move away from each other. So remember, I want you to think about the term pulling apart. So whenever you're going to explain divergent boundaries, I want you to think about pulling apart. So this is when two plates move away from each other, new land can form here, like at the bottom of the ocean where magma comes up and makes a new crust. So again, divergent boundaries, this is when two plates move away from each other. And as they are moving away from each other, new land can be formed there. All right. The next type of plate boundary is convergent boundary. Now, the term that I want you to think about when you are explaining convergent boundaries is crashing together. When we are talking about divergent boundaries, I want you to think about pulling apart. When we are talking about convergent boundaries, I want you to think about crashing together. Now, this is when two plates push against each other. One plate might go under the other, or they might both push upward from forming mountains. The next type of plate boundary that I want you to think about is transform boundaries. Now, for this boundary, I want you to think about sliding side by side. When you think about divergent boundaries, think about pulling apart. When you think about convergent boundaries, I want you to think about crashing together. Now, when you're thinking about transform boundaries, think about sliding side by side. So this is when two plates slide past each other, and this can cause us to have an earthquake. All right, so those were the types of boundaries. Now we're going to look at global distribution of plate boundaries. Now, the global distribution of plane boundaries means where on Earth the edges of the plates are found, in simple words. So, plate boundaries are not randomly spread out. Most of them are found along the edges of continents and oceans. And for those of you who are not sure what plate boundaries are or what we're talking about, now plate boundaries are the places where two pieces of the Earth's crust called plates meet. Now, the Earth's outer layer is like a jigsaw puzzle. We did say that already, but just a revision for those who are just catching on. So, the Earth's outer layer is like a big jigsaw puzzle made up of these plates. Now, the edges where the plates touch are called plate boundaries. All right, and we already look at the different types of plate boundaries, and I did say you should think about moving apart, divergent boundaries, crashing into each other, convergent boundary, sliding past each other, transform boundary. All right, so we are looking at the global distribution of plate boundaries. So, as I was saying before, the global distribution of plate boundaries means that where on Earth the edges of the plates are found, where on the earth are the edges of the plates found? Now, in simple words, plate boundaries, they are not randomly spread out. So most of them are found along the edges of continents and oceans. For example, the Ring of Fire around the Pacific Ocean has many plate boundaries. That's why countries like Japan, Indonesia, Chile, they have a lot of earthquakes and volcanoes. Now, some boundaries are found under the ocean, like the Mid-Atlantic Ridge, where new crust is forming. Others are found on land. So plate boundaries are found in certain patterns around the world, and that's why we often see earthquakes, volcanoes, and the other natural disasters happening because of plate boundaries. All right, now we're going to look at the Caribbean and adjacent plate boundaries. Now, as we established before, the Earth's crust is made up of large pieces called tectonic plates. Now, like a giant jigsaw, imagine a giant jigsaw puzzle, right? That's how the tectonic plates are. These plates, they move slowly and sometimes they bump into each other. Do you remember talking about types of plate boundaries? Yes, sometimes they bump into each other, sometimes they pull apart, or sometimes they slide past each other. The Caribbean region sits on one of these plates, and it is called the Caribbean plate. All right, so the main plates that are in our region are we have the Caribbean plate, which covers countries like Jamaica, Haiti, the Dominican Republic, Puerto Rico, and parts of Central America. We also have plates around the Caribbean plate. So we have the Caribbean plate, which cover those countries, and around the Caribbean plate, we have North American plate, which is to the north. Those countries are Cuba, Bahamas, and the Gulf of Mexico. We have South American plate to the south, which is near Venezuela and Colombia. We have the Caucasus plate to the west, near Central America. And we have the Nazca plate to the southwest in the Pacific Ocean near South America. Now, why is this important for us to know about Caribbean and the adjacent plate boundaries? Now, the edges where these plates meet are called plate boundaries, right? These are places, as we said before, where earthquakes, volcanoes, and mountains often happen. That is why the Caribbean sometimes experiences natural disasters such as earthquakes and volcanic eruption because the Caribbean is sitting at the edge of moving plates. All right, guys, but it would be good if you can go back to your textbook so that you can see a diagram or labeled map showing the Caribbean and the adjacent plate boundaries. All right, because you know this is a syllabus. We don't have any maps to show. Now we're going to look at formation and distribution of earthquakes, volcanoes, and fold mountains. So we're going to look at earthquakes. What are earthquakes? Now, earthquakes are sudden shaking of the Earth's surface. How are they formed? They happen when tectonic plates big pieces of the earth crust. They grind, slide, or crash into each other. So earthquakes are formed when big pieces of the earth crust called tectonic plates grind, slide, or crash into each other. Now the pressure builds up at the plate boundaries until it is released suddenly, causing the ground to shake. Where do earthquakes happen? Earthquakes happen mostly along plate boundaries, and we did establish that plate boundaries are, do you remember? Where plates meet. Example, the Caribbean region has earthquakes because the Caribbean plate meets the North American plate. All right, guys. Volcanoes, what are they? Volcanoes are mountains that release magma, and that's hot molten rock, from inside the earth. How are they formed? When plates move apart, so the plates they are moving apart, or one plate goes under another, magma rises through the cracks and erupts. Over time, the lava cools and builds up to form a volcano. Now, where do volcanoes happen? Volcanoes mostly happen along convergent boundaries. And what did we say convergent boundaries mean? Where plates do what? Collide. So volcanoes mostly happen along convergent plates where plates collide, or divergent boundaries where the plates are doing what? In divergent boundaries, the plates are what? They are pulling apart. Now, example, let's look at Montserrat and St. Vincent are in the Caribbean, and we know that these countries, they have active volcanoes. All right. So we looked at the formation and distribution of earthquake volcanoes. Now we're going to look at fold mountains. What do you think fold mountains are? If you are thinking that, fold mountains are huge mountain ranges made up when the Earth's crust is pushed up and folded. So when the Earth crust is pushed up and folded, fold mountains are formed. So these are just huge mountain ranges. How are they formed? When two plates collide, the land between them is squeezed and folded upward. This happens over millions of years. Where do fold mountains happen? Mostly at convergent plate boundaries. So let me ask you now, what happened at convergent plate boundaries again? The plates are doing what? What are the plates doing, students, at convergent plate boundaries? They are crashing into each other. Very good. All right, so fold mountains, they happen at convergent plate boundaries. And as I said before, because the syllabus does not come with diagrams or maps, while I'm elaborating on the different topics, you can have your notebook with you or your textbook to look at diagrams showing what I'm talking about. All right. Now we're going to look at intrusive volcano features such as silts and dikes and batholiths. We're going to look at extrusive volcano features. Alright, so go to your notebook or your textbook and read up on what are intrusive volcano features and what are extrusive volcano features. Hope you are reading it. Now, intrusive volcano features, these are formed inside, as the word intrusive suggests, inside the earth. So when magma cools beneath the surface, we have silts. What do we mean by silts? Magma spreads out sideways between layers of rock and hardens. It looks like silks looks like a flat horizontal sheet of rock inside the earth. Dikes, magma pushes straight up or across through cracks in rocks and hardens. Dikes are vertical or slanted walls of hardened magma. Batholiths, these are very large blobs of magma that cools deep inside the earth. They take a long time to form and can be hundreds of kilometers wide. So over time, erosion can expose them at the surface. Now, extrusive volcano features. These are forms at the Earth's surface. So when magma, what we call lava, comes out during a volcano eruption. So from when there's an extrusive volcano, some of the features that you will see are you'll see the volcanic cone. So when lava, ash, and rocks come out of a volcano and pile up, they form a cone-shaped mountain. So you could see that at the top of the mountain. Guys, you have to use your diagrams from your textbook to follow what I'm saying because the syllabus do not give us diagrams. All right, there are different types of volcanic cones. So you could have a shield cone, which is wide and gentle slope. You could have a composite cone, which is tall and steep. You could have a cinder cone, which is small and made mostly of ash and rock. So you can look at the volcano in your textbook and look at what type of volcano cone is at the top. Now, lava plateaus, these form when thin running lava flows out quietly and spreads over a large area. The lava cools and hardens into a flat, wide surface called a plateau or a plateau. Now, what are the changes in intrusive and extrusive volcano features over time? So, what happened to the volcano cones and the lava plateau over time in an extrusive volcano? What happened to the features of an intrusive volcano, such as the silk and the dyes, etc., over time? Now we're going to look at that. Now, intrusive features, we did say those are happening inside the earth. Like silk, dyes, and batholiths, they form underground. They're happening inside of the earth. Over thousands or millions of years, the rocks above them get worn away by weathering, weathering could be caused by rain, wind, and temperature changes, and erosion also. So as the top layers wear away, the intrusive features becomes exposed at the surface. They can form hills, cliffs, or rock outcries that we can see today. All right. So those are the things that happen to the future features of an intrusive volcano over time. So they can form hill, cliffs, or rock outcrops. Now, let us look at what happened to the features of extrusive volcanoes over time. I will say that intrusive happens within inside the earth. Extrusive features, they're what is happening on the surface. So extrusive features like volcanic cones and lava plateaus are already on the Earth's surface. Over time, wind, rain, rivers wear them down. So volcano cones can lose their shape or size. Craters may get filled in or collapse. So lava plateaus can crack, break apart, or get covered by soil and plants. Old volcanoes can become dormant, that means they're not active, or extinct, and eventually just look like a regular hill or mountain. All right, so those are the things that happens to intrusive and extrusive volcano features over time. So those are the changes. Now we're going to look at external features. And guys, you have to have your textbook beside you while we're going through this syllabus because the syllabus do not comes with diagrams to show or to explain what we're talking about. All right. External forces. We're going to look at the definitions of denudation, weathering, mass wasting, and erosion. We're going to look at weathering types. So if they ask you about weathering types, you know they are physical, chemical, biotic. The processes of weathering. If they ask you about what are the processes of weathering, you should be able to talk about carbonation, oxidation, solution, frost action, pressure release, temperature changes, biotic. If they ask about mass wasting, they're talking about landslides and soil creep. And then we're going to look at the conditions influencing landslides and soil creep. So the first thing we're going to look at is the definitions of the word. What is denudation? Denudation is the wearing away and removal of the Earth's surface over time. It includes all the natural processes that break down rocks and shape the land. Now, what is weathering? Weathering is when rocks break down into smaller pieces because of wind, rain, heat, or plants. It does not move the rock, it just breaks it apart. What is mass wasting? Mass wasting is when rock and soil move downhill because of gravity. Example, when you have a landslide, that's a type of mass wasting. Erosion is when broken down rock and soil are carried away by wind, water, or ice. It involves movement of the material. All right, so just a quick reminder of the definition of the words. So weathering breaks the rock, erosion moves the pieces, mass wasting moves rock downhill, so it moves rock downhill. Denounce, which where am I? Denudation means, what did we say denudation means? Denudation, what's that? Wearing away and removal of the Earth's surface over time. Very good, guys. All right, so we are learning. We're now going to look at the types of weathering. Get your textbook, guys. Follow the topic. So we're on weathering. Find weathering in your textbook or your notebook. Look at the diagrams that are there because the syllabus do not come with diagrams. So as I am explaining, you can follow in your textbook. All right, guys, what did we say weathering is? Based on the definition above, what is weathering? Very good. So weathering is the breaking down of rocks into smaller pieces right where they are. There is no movement. So the rock is not moving. Right where the rock is, weathering is breaking down of rocks into smaller pieces right where they are. No movement. Now, there are three main types of weathering. We have physical weathering, which is also called mechanical weathering. Now, this happens when rocks break apart without changing what they are made of. Two causes of physical weathering, also called mechanical weathering, are temperature changes. So rocks expand in heat and contract in cold. Another cause of physical weathering is pressure release. So when overlying rocks are removed, so pressure release means the overlying rocks, they are removed, resulting in physical weathering. Chemical weathering, this happens when rocks are broken down by chemical reactions. Chemical reactions are caused by rainwater mixing with gases in the air to form weak acids. Another cause of chemical weathering is water reacting. So when water react with minerals in the rock, we have chemical weathering. Biological or biotic weathering. This happens when plants, animals, or people help break down rocks. Causes: roots of plants growing in cracks and splitting rocks, resulting in biotic or biological weathering. Animals: animals digging and loosening soil and rock also result in biological or biotic weathering. Humans: when we dig into the earth for mining or to build or to construct buildings, that also result in biological or biotic weathering. All right, so just a quick summary of the weathering types. So the three types of weathering are physical, chemical, biological, or biotic. Physical weathering is caused by temperature, ice, and pressure. Chemical weathering is caused by water and acids changing rock. Biological weathering is caused by plants, animals, or humans. Alright guys, so if you get any question asking about the weathering types, you should definitely be able to explain what the weathering types are. So we're going to explain again what is weathering. All right, I know we did this definition. I know we looked at this definition 2 times already, but we're still going to look at it until someone gets it. All right, so weathering is a process by which rocks are broken down into smaller pieces without moving them. All right. Now, what are the processes of weathering? You must know these guys. They're right here. Guys, I want you to know what are the processes of weathering. All right, and we're going to explain each one of these processes. So we have carbonation, which is also chemical weathering. So rainwater, as we explained before with chemical weathering, rainwater mixed with carbon dioxide in the air to form a weak acid. This acid dissolves rocks like limestone. Example, caves form in limestone because of carbonation. So again, carbonation is when rainwater mixed with carbon dioxide in the air to form a weak acid. The acid dissolves rocks like limestone. So the rocks that you see in caves form what is called limestone because of carbonation. Oxidation, also a form of chemical weathering. This happens when oxygen reacts with minerals in rocks, especially ones with iron. It causes the rocks to rust, weaken, and crumble. Example of oxidation: rocks turning reddish brown and breaking down. Solution: some minerals, when you have some minerals dissolving in water completely. Minerals dissolving in water completely. This weakens the rock. So if they ask for example of solution, you can talk about salt or chalk dissolving in rainwater. Frost action, which is a form of physical weathering. Water gets into cracks in rocks, freezes, and then expands. So this makes the cracks bigger and breaks the rock. Example, rocks breaking in cold places like mountains. So frost action is when water getting into cracks in rocks, freezes, and then expand. Simple. Pressure release: when heavy rocks on top are removed, the rocks underneath expand and crack. The pressure is released and rocks break apart. Temperature changes: rocks expand when it's hot and shrink when it is cold. Repeating this over time causes cracks and breaks the rock. Biotic or biological weathering: living things break down rocks caused by plant root. So when you have plant root growing in cracks, it results in biotic weathering. When you have animals digging into the earth or into rocks, it breaks down the rocks and cause biological weathering. When we have humans digging, building, or mining the earth, it breaks down rocks and cause biotic weathering. So a simple summary, if they ask you about the processes of weathering, they are carbonation, oxidation, solution, frost action, pressure release, temperature change, and biotic. If they ask you what type of weathering does each processes comes under, carbonation is chemical weathering, so acid rain dissolves limestone. Oxidation is an example of chemical weathering. Oxygen causes rocks to rust and break. Solution is a type of chemical weathering. What happens in solution is that minerals dissolve in water. Frost action is a type of physical weathering. Then this is when water freezes into cracks and breaks the rock. Pressure release is a form of physical weathering. The rocks crack when heavy layers are removed. Temperature change is a form of physical weathering, and this happens when rock cracks from heating and cooling. Biotic is a type of biological weathering, and this is when plants, animals, or people break rocks. All right, so if they ask about the processes of weathering, you should be able to do so. All right, guys, please remember to follow in your textbook because geography, you have to have diagrams to support what you're saying, okay? And the syllabus does not come with any diagrams. Now we're going to look at mass wasting. And we're going to look at two types, landslides and soil creep. We're going to also look at the conditions influencing landslides and soil creep. Mass wasting. So if you see any question on the geography paper asking about mass wasting is also called mass movement. And this is when rock, soil, or mud moves downhill because of gravity. This can happen slowly or quickly depending on the type. Now, what are the examples of mass wasting? We have landslides. So when rock, soil, or mud moves downhill because of gravity, which is mass wasting, we have what we call landslides. Now, these happen quickly when large amount of rocks or soil suddenly slide down a slope. Have you ever seen a landslide, guys? It is fast and it is dangerous. Now, what do we mean by excuse me? What do we mean by soil creep? This is a very slow movement of soil down a gentle slope. You may not notice it right away, but over time you'll start seeing fences or trees may lean downhill. So then you'll know we had a soil creep. Alright, so landslides happen quickly when large amount of rocks or soil suddenly slide down a slope. It's fast and dangerous. Soil creep on the other hand happens very slow movement of soil down a gentle slope. You may not notice it right away, but over time you'll see your fences or your trees, they may be leaning downhill. Now we're going to look at the conditions that influences landslides. So guys, if you have ever excuse me. So guys, if you have ever experienced or seen a landslide, what are some of the things that you notice that could have caused a landslide? Did you notice if the land was steep? So steep slopes are more likely to have landslides. So if the land is steep, you're most likely to experience landslide. Soil creep happens on gentle slopes. So conditions that influences landslide and soil creep, slope. Steep slopes causes landslides. Gentle slopes causes soil creep. Another condition that might influence landslides and soil creep, rainfall. So every rain soaks the soil, making it heavy and slippery. This can trigger landslides and help soil creep. Types of soil or rock could also cause landslide and soil creep. So loose, soft soils move more easily than hard rocks. So type of soil slash rock could also cause landslides and soil creep. Vegetation could also cause landslides and soil creep. So areas with less plants or less trees are more likely to slide. We know that the roots of trees are very important in helping to curtail or prevent soil erosion. So areas that have less vegetation, they are more likely to experience landslide or soil creep. Another condition that may influence landslides and soil creep is human activity. So cutting down trees, building roads, mining can weaken the land, resulting in landslides or soil creep. So just to summarize what we just said. So mass weather wasting is gravity pulling soil and rocks downhill. Landslides, they are fast. Soil creep, they are slow. They are influenced by landslide and soil creep are influenced by the slope of the land, rain, soil type, vegetation, and human actions. Alright guys, so I hope you are following. Please remember to like this video guys. Leave a comment. Let me know that you are learning guys. Leave a comment. And also remember to watch the ads. That's the only way you can support my effort in helping you to prepare for your CXCA examination. Now we're going to look at rivers. So go to your textbook, guys, or your notebook and find the topic that speaks on rivers. We're going to look at the water cycle. I know, as I said before, the syllabus does not show diagrams, so I want you to use your textbook to find where the water cycle where it speaks about water cycle, and you're going to look at the diagram showing the water cycle while I am explaining it. We're going to look at how water flows on reaching the surface. We're going to look at river processes, and if they ask you about what are the river processes, you should be able to talk about erosion, transportation, deposition, river valleys. We're going to look at land farms, rapids, waterfalls, gorges, lakes, floodplain, braiding, all of those we're going to look at. And finally, we're going to look at drainage patterns. All right, so I'm going to give you a minute to a few seconds to find the page in your textbook that speaks about rivers. Are you ready, guys? Let's go. So the water cycle is the way water moves around the earth from the air to the ground and back again. In simple words, guys, I'm trying to do it as simple as possible. So water cycle is the way that water moves around the earth from the air to the ground and back to the air. Now, what are the steps in the water cycle? We have evaporation, and this is where the sun eats up water in rivers, lakes, and oceans, turn it into water vapor or what we call gas. Condensation. The water vapor cools down in the sky and forms clouds. Precipitation. Water falls from the clouds as rain, snow, or hail. Collection or runoff, the water flows over the land or soaks into the ground, going back into rivers, lakes, or sea. So in simple terms, we just explain how rain happens. So we have evaporation. The sun eats up water from rivers, seas, and oceans. It turns into water vapor. The water vapor cools down in the sky, forms clouds. The clouds, water falls from the clouds as rain, snow, or hail. And the water that falls on the earth, it flows over the land, soak into the ground, going back into rivers, lakes, or the sea. Now we're going to look at how does water flows on Earth's surface. How water flows on reaching the surface. So what happens after rain falls? Think about it. Rain is falling. What happens after the rain? Well, if you're thinking that some water soaks into the soil, this is infiltration. So we have water soaking into the soil after rain. Some water runs off the surface into streams and rivers. This is runoff. And some water flows downhill because of gravity and eventually reaches the sea. So all water flows on reaching the surface. Some water soaks into the soil. This is infiltration. Some water runs off the surface into streams and rivers. We call this runoff. And some water flows downhill because of gravity and eventually reaches the sea. All right, so we're going to look at the river processes, and they are erosion, transportation, deposition. Now I know that some students are looking at this syllabus and they're asking themselves, what do they mean by river processes? Now river process are the natural actions a river uses to shape the land as it flows from the source, which is the start of the river, to the mouth, which is the end of the river. Now there are three main river processes. They are erosion, transportation, and deposition. Erosion. This is when the river wears away the land, the riverbank and the riverbed, what you call riverbank and riverbed. So it's caused by erosion, where the river wears away the land. The river cuts into the land, forming valleys. The river cuts into the land, forming valleys and waterfalls. Example, a river cutting into rock to form a steep valley. So if you live in a country where you see there's a lot of waterfalls coming from the top of the mountain, and we're like, oh God, how did that happen? Well, it is erosion. So the river cuts into the land, forming valleys and waterfalls. Another river process is transportation. This is when the river carries away the material, as it suggests, transportation. Something is carrying something somewhere. So the river is carrying material. This is when the river carries away the material, rocks, sand, soil. It's eroded. So transportation, this is when the river carries away the material, rock, sand, soil. It's eroded. Now the river moves this material downstream. Example, let me see if I can think about example of transportation. Oh, let's look at pebbles rolling along the riverbed. Have you ever seen pebbles rolling along the riverbed? That would be an example of transportation. The river is carrying away the material, then it erodes it. All right. Deposition. This happens when the river slows down and drops the material it was carrying. Isn't that amazing? So the river slows down, then it drops the material it was carrying. This forms features like sandbars, riverbanks, or deltas. Example of deposition would be, let's say a river forming a delta where it meets the sea. That would definitely be an example of deposition. So the three processes are erosion, transportation, and deposition. So guys, just to summarize river processes, what we just talked about, just in a few sentences. All right, so river processes are the ways a river shapes the land as it flows. There are three main types of processes: erosion, the river wears away rock and soil from its bank and bed; transportation, the river carries the eroded material downstream; deposition, the river drops the material when it slows down. These processes help form features like valleys, waterfalls, sandbeds, riverbeds, and deltas. Now we're going to look at river valleys. A river valley is the low area between hills or mountains where a river flows. So have you ever gone somewhere and noticed a river flowing between a hill or a mountain? That is called a river valley. At the start, which is the upper course, the rivers are small but flow quickly downhill. The fast water cuts into the land, creating a V-shaped valley. Over time, the valley becomes wider and deeper as the river continues to erode the land. So a V-shaped valley in a mountain area would definitely be an example of a river valley. So now we're going to explain, we look at river valleys, we're going to explain landforms. So examples of landforms, we have rapids, all of the examples here, guys. I'm not sure if I'm going to go through all these examples, but I'm going to look at as much as possible for revision purposes. All right, so the first landform we're going to look at is rapid. Now, what are rapids? Rapids are sections of a river where the water flows very fast over rocks. They are formed where hard rock is mixed with soft rock, causing the riverbed to be uneven. The water becomes rough and bubbly. Example of rapids would be, say, a fast-flowing stretch of a river with rocks and small splashes. Waterfall. A waterfall forms when a river flows over a high ledge or cliff. The river erodes the soft rock below hard rock, causing the hard rock to fall. Over time, the waterfall moves backward and forms a deep plunge pool. A gorge is a narrow, steep-sided valley formed when a waterfall moves back over time. The water cuts deep into the land, leaving a long channel behind. Floodplain is a flat area beside a river that gets flooded when the river overflows. When the water slows down, it drops sand and silt, making the soil rich and fertile. So if you live in a area, plain areas are good for farming. Braiding happens when a river splits into small channels separated by sand or gravel bars. This happens when the river carries a lot of material and loses energy, dropping it in the channel. All right, guys, and the others, I want you to do your own review of the other landforms. Let's look at two more. Point bar, also called the slip-off slope, is the gentle slope on the inner bend of a river. The river moves slowly here and drops sands and pebbles. Delta is a landform at the mouth of a river where it meets the sea or a lake. When the river slows down, it drops lots of sediment, sand, silt, clay, forming new land in a fan or triangle shape. Deltas often have many channels called distributaries. All right, so those are the landforms. At least study two or three, guys. So if you get a question asking you about landforms, you should be able to list at least three of these and explain what they are. Now we're going to look at drainage patterns. Guys, so what is a drainage pattern? Now, a drainage pattern is a shape or design made by rivers and streams as they flow across the land. It looks like a pattern from above. It might look like a tree, it might look a star, it might look like a net, depending on the landscape and the rock type. Now, there are three types of drainage pattern. Dendritic pattern, we have radial pattern, and we also have trellis pattern. And we're going to look at each of these drainage pattern individually. Dendritic pattern, it's a tree-like pattern. It looks like a tree. And this is the most common pattern. The rivers and streams branch out like the roots or branches of a tree. So if you live in central Jamaica, you might be seeing, the river looking like a tree, a dendritic pattern. It forms on flat or gently sloping land with uniform rock. The river and streams branch out like the roots or branches of a tree. So that's the dendritic pattern. The radial pattern, also called the spoke-like pattern. So the river flows outward in all directions, forming a central high point like a mountain or volcano. It may look like spokes on a bicycle wheel. So have you ever seen the spokes on a bicycle wheel? That's how the radial pattern looks like. And if you live around the Blue Mountain area there in Jamaica, you will see the radial pattern looking like a bicycle spoke around Blue Mountain Peak in Jamaica. Alright, trellis pattern, it's a grid-like or ladder pattern. So the river flows in a main direction with smaller streams joining at right angles, 90 degrees, formed in areas where flooded rocks are ridges and valleys. So if you live in the limestone area or you live in any ridges, do you live near any ridges or any valley, you might see a trellis pattern there where the river flows in a main direction with smaller streams joining at right angles, and it looks like a ladder. So quick summary of drainage. The three types of drainage patterns are radial, trellis, dendritic patterns. Dendritic pattern is a tree, looks like a tree branch. Radial pattern looks like a bicycle spokes. Trellis pattern look like a ladder. The dendritic pattern, it forms on flat land with soft rock. Radial pattern forms where volcanoes or high mountains are, and trellis forms where folded rocks or ridge and valley areas. All right. So if they ask you about examples where you can find each, the dendritic pattern can be seen in central Jamaica. Radial pattern can be seen in the Blue Mountain Peak area, and the trellis pattern can be seen parts of limestone areas. All right, so that's it on drainage patterns. Guys, please remember, use your textbook. So as I'm going through the different topics, ensure that you have your textbook or your notebook and you are following. Now we're going to look at limestone environment. We're going to look at the characteristics of limestone, process occurring in limestone areas, and we're going to look at the karst landforms in the Caribbean. All right, so the first thing we're going to look at, what are the characteristics of limestone? So if you're asked this question based on the syllabus, they are expecting you to write about chemical composition, structure, and the permeability of limestones, which we're going to look at. So these are the characteristics that we're going to look at. So when we talk about limestone, we are referring to a sedimentary rock made mostly from calcium carbonate. It comes from the remains of sea creatures like shells and corals that have been pressed together over time. Now, what are the characteristics of limestone? We're going to look at the chemical composition. Limestone is made up of calcium carbonate. The structure of limestone, it's usually layered, can have joints. These cracks make it easy for water to pass through. Permeability, which means water can pass through limestone easily. All right. Processes occurring in limestone. Now, rainfall is slightly acidic, and that means it contains carbonic acid from mixing with carbon dioxide in the air. So when this acid rain falls on limestone, it causes a chemical reaction, right? Now, what are the processes that happens in limestone areas? The first one we're going to look at is carbonation. A matter of fact, this is the only one we're going to look at. Guys, you can do some research on the other processes. So carbonation is when acid rain dissolves the calcium carbonate in limestone. This process widens cracks and creates special features. Now, what are limestone landforms that are created both on the surface and underground? So we're going to look at these examples, but I'm going to categorize them as surface landform or underground landform. All right. So the first one we're going to look at is surface landform. Example, surface, as its name suggests, surface landform, it is seen on top of the land. So we're going to look at swallow holes, also called sinkholes. Now, places where river disappears into the ground through cracks. The water then flows underground, causing sinkhole. So you used to have a river there, the river disappear into the ground through cracks. The water then flows underground. It's called a sinkhole. Caves. Caves are examples of underground landforms, meaning it is found beneath the surface. Now, caves are formed when acidic water widens cracks underground, creating large hollow spaces. Caves are examples of underground landform. They are formed when acidic water widens cracks underground, creating large hollow spaces. All right, so that's how caves are formed. The next one we're going to look at is, all right, so we're going to look at stalactites. And these are examples of underground landforms. They are found beneath the surface. Now, stalactites are icicle-shaped features that hung from the roof of a cave. They are made when dripping water leaves behind calcium carbonate. Stalagmites, they grow up from the cave floor under stalactites, also form when dripping water leave deposits. Pillars or columns form when stalactites and stalagmites meet and join together. So if they ask you about the features of underground and surfaced landforms, you should be able to explain them and give examples. If they ask you about the processes occurring in limestone areas, you should also be able to explain those. All right, so we're going to look at coast. Go to the page on your textbook that speaks about coast. We're going to look at wave types. There are two types of wave types. It can be constructive or destructive. We're going to look at those. Wave processes, we're going to explain those, and resulting landforms. So as a result of wave processes, what are the landforms that are formed? We're going to look at those. We're going to look at the types of coral reefs in the Caribbean, fringing or barrier. We're going to look at the location, distribution of coral reefs in the Caribbean, and also conditions that are necessary for the successful formation of coral reefs. So I want to go to the page on your textbook that speaks about coast. Now, waves are mountains of water on the sea's surface caused mainly by wind. Now, there are two main types of wave. So if CXC asks about the types of wave, they are constructive and destructive wave. Now, a constructive wave, these waves build up the beach. Constructive waves, they build up the beach. They have strong swash, that means water moving up the beach. They have a weak backwash, meaning water moving back to the sea. They deposit materials like sand and pebbles. The result of a constructive wave, we have beaches, splits, and bars being found. So as a result of constructive wave, we have beaches, spit, and bars being formed. Now, what do we mean by destructive waves? These are waves that break down the coast, as destructive suggests, destroying something. They are breaking down the coast. They have a weak swash and strong backwash. They erode the coastline by removing sand and rock. As a result of destructive waves, we have cliffs, caves, and wave-cut platforms. All right. Now, what are the wave processes? Wave processes are the actions that shape the coast. They include, so what are some of the actions that can happen that changes the coast? Erosion. And we already established that erosion is the wearing away of rock. Transportation is another wave process. This is moving materials. Now, waves move materials along the coast through longshore drift. Another wave process, deposition, dropping materials. So when waves lose energy, they drop sand and pebbles, forming landforms. Now, those were the wave processes. They are deposition, dropping materials, transportation, moving materials along the coast, and erosion, wearing away of rocks. Now, what are the different landforms that are formed from the wave processes? All right, so the first one is erosion. The first wave process is erosion. So as we said that erosional landforms, they are made by destructive waves. So landforms that are formed from destructive waves, we have cliff, wave cut notch, wave cut platform, headland, bay, cave, arch. So the landforms that are formed as a result of the first wave type, constructive wave, they are cliff, wave cut notch, wave cut platform, headland, bay, cave, arch. Now, what are some of the landforms that are formed from depositional landforms? These are constructive waves. We have beach, spit, bar. So just to summarize what we just learned about wave processes and the result of landforms from wave processes. We learned that there are two types of wave, constructive, destructive. Constructive wave, they build up the coast. Destructive wave, they break down the coast. Landforms that are formed from constructive wave, beaches, spits, and bars. Landforms that are formed from destructive waves, cliffs, wave-cut platforms, caves, arches, and headlands. All right. Now we're going to look at what are the types of coral reefs in the Caribbean. And there are two types, fringing and barrier coral reefs. Now, there are two main types of coral reefs in the Caribbean. They are fringing and barrier coral reefs. What do we mean by fringing coral reefs? These reefs grow close to the shore. They are attached directly to the land. You can swim out of them from the beach. They grow in shallow water and are easiest to access. Example of fringing reefs would be along the coast of Jamaica. So if you have ever been to Negril, you will definitely see some examples of fringing reefs there. So they grow close to the shore and they are attached directly to the land. You can use your textbook to look at diagrams of what fringing reefs are. Barrier reefs, these are reefs that are further away from the shore. A lagoon, which is a calm water area, is found between the reef and the land. They are usually larger and deeper than fringing reefs. So the Belize Barrier Reef is the second largest in the world. Now, what do we mean by location, distribution of coral reefs in the Caribbean? Now, the main location of coral reefs in the Caribbean are Jamaica. So if you have been to Negril, as I said before, Negril, Montego Bay, or Port Royal, you will see examples, a lot of coral reefs in those areas. If you have been to Belize, Belize is the home of the Belize Barrier Reef. Bahamas, many fringing and patch reefs are there. If you have been to Barbados, St. Lucia, Grenada, you'll find a lot of fringing reefs around their coast. All right, so they are often found on the Caribbean coast of islands and along continental shelves. Now, what are the conditions that are necessary for coral reefs formation? Now, coral reefs needs very specific conditions to grow and survive. Some of the conditions are warm water, 24 to 28 degrees Celsius. Why do we need warm water for the formation of coral reefs? Corals grow best in warm tropical water. Shallow water, less than 50 meters down. Why is this so needed? Sunlight must reach the coral to help it grow. So it cannot survive by itself in water. It needs sunlight to grow. We need clear water. Corals, they need sunlight, and muddy or polluted water blocks it. So if the water is muddy or polluted, it's going to block the coral and prevent it from growing. They need clean water. Pollution and chemicals can kill corals. Salt water, they need salt water. Corals do not grow in fresh water. Another condition, calm water. So strong waves or storms can break or damage coral. So quick revision of what we have just talked about. There are two types of waves, constructive and destructive. We looked at types of coral reefs in the Caribbean, fringed reefs, they grow close to the shore. Barrier reefs, they are far from the shore with a lagoon in between. Found in warm water, we talk about the conditions that were necessary for successful formation of coral reefs. So they need warm water, clean water, salt water, and all the other conditions that we spoke about. Alright guys, I'm going to stop here. I don't want the video to be too long. So this is part 1 of the geography syllabus, CXE syllabus. We're doing a marathon to help us prepare for the geography examination. Look out for part 2, guys. Please remember to subscribe if you have not done so. Guys, please remember to leave a comment and like this video. Look out for part 2 of the geographic syllabus revision.